Well, welcome everyone. I'm Jay Galasso with the Alt-E store, and I'd like to welcome you to our next session. This session is going to be presented by OutBack Power. We have Mark Mays from OutBack and Bill Dougherty from OutBack. They're going to be our hosts here for today's session. I'd like to remind everybody that we do have a networking session after all of today's technical sessions that'll start at 3 o'clock, and Mark and Bill will be available then for any additional questions that you may have that they don't get answered during this session. So with that, I'd like to turn it over to Mark.
Okay, thanks, Jay, and welcome everybody. Good afternoon or morning, whichever the case may be. A bit of a windy day here on the beach, but somehow I'll suffer through that. Actually, I'm in kind of a large vacant room right now, so I apologize in advance about the echo. It's not your audio system, it's just the room I'm in. Hopefully that's not too inconvenient for everyone. Bill Dougherty is going to be answering your questions such as he can. Bill's a pretty sharp guy. I'm sure he'll be able to answer most of your questions. He'll try and do it in real time as much as he can. And as Jay mentioned, we are going to be having a little networking session at 3 p.m. Eastern time, and I will be there, as will Bill, and we'll be able to handle any other questions that don't get answered here. So without any further ado, I'm going to go ahead and get right down to today's topic. Okay, today we're going to talk about OutBack's SytemEdge sizing tool. It is a UL9540 selector tool, if you will. All of our SytemEdge packages are UL9540 certified, and we'll talk just about what exactly that means. We'll be demonstrating the tool live on the internet. It is a live interactive tool you can use on our website. Yeah, so we'll just move right along here. Okay, so the UL9540 system, it's an energy storage equipment certified as a system. So UL9540 ESS, it's a UL 1973 certified stationary battery pack. And it's also a UL 1741 certified inverter. So it's those two things together. And you can see on the right-hand side of the slide, you see the UL9540 mark on our integrated battery rack, also known as the IBR3, the 3 shelf, and the IBR2, the 2 shelf. But you notice there's also an LI version. And so this was certified using the Simplify batteries. So this mark is only with our UL 1741 inverters and the Simplify lithium-ion batteries, okay? In fact, the UL9540 certification only applies to lithium batteries. It does not apply to lead-acid batteries. So that doesn't mean you can't have lead-acid batteries. It just means that in places that requirements such as California, they do require a UL9540 system where lithium-ion batteries are going to be used. Okay, so it's basically a rigorous thermal electrical testing that we do to make sure that the integration is performing both safety-wise as well as all our parts and pieces are going to work. Back in the day when I first started with OutBack 10 years ago, people would get a pallet full of parts, put it together, and some people were definitely more successful than others putting it all together. But the other reason we came up with the tool portion of this is that we wanted to take we wanted to eliminate a poorly integrated custom systems that are unsafe and underperform. And in the case of lithium-ion batteries, they do have a little bit higher instance of thermal runaway, but even lead acid batteries, if overcharged, can have thermal runaway. So you can set any batteries on fire if you do things the wrong way. So, but anyway, it's just for the most part, we want to make sure that people get a system that's safe and works together. And I have to say, I've been an applications engineer with OutBack for 10 years. And maybe some of you that attended my workshops in the past have heard this before, but 90% of the problems that I see fall into one of three categories. Either it wasn't designed properly, it wasn't configured properly, or it wasn't sized properly. And the sizing tool eliminates virtually all three of those problems. Now, yeah, of course, we have product failures occasionally, like everybody does. But the main thing is that you're going to get a system, it's going to be designed properly, sized properly, and these are just single inverter systems, okay? You can add batteries to them, like when we get to that stage and you see, oh yeah, the inverter fits, but boy, I'm a little shy on batteries. You can always add batteries to the system, okay? So these are the two inverter types that are part of a SytemEdge package. So a lot of you are familiar with these products, but just to give you just the basic specifications, the Flex Power Radian. So this is a system. It's the inverter, the load center, either 1 or 2 charge controllers, depending on whether you have a 4 kW or kVA or an 8 kVA inverter, and then the Mate3 system controller, okay? So this is a system. The Skybox is the equivalent of all these things. The PV is built in. Here's the balance of system, load center, and then the inverter portion up here. So these are equivalent systems with different specifications. You can see that the Skybox is a 5 kVA continuous power. That's also its limit with regards to surge. So this is not a surge inverter. It's a transformerless design, and it's that transformer that gives the surge capability with the Radian. So with a 4 kVA Radian, you get 8 kVA surge. Likewise, with the 8 kVA Radian, you get 16 kVA surge. And that's the 100 millisecond spec. That's those first 5 cycles of a motor turning on is usually adequate to handle that surge. We also have some time of use smart grid features, if you will, and it's a little bit basic with Radian. We can drop the grid up to 3 different times a day. So if you're trying to match, rate structure with your utility, you can do that. Skybox is more advanced. You can put in the entire rate schedule. You can put an external CT at the main panel and self-consume all the way out to the main panel. So it's got some nice capabilities to it. The Skybox is indoor rated. The Radian is indoor rated. Skybox is a NEMA 3R. The Radian is integrated PV. You can say, since the FM100s are all mounted onto this back panel. This is definitely a 2 or a 3-man lift, though. This is it's not a light package to hang up. But the Skybox, definitely, you can definitely, a single person, I've done it, can install a Skybox, no problem. Off-grid, yes, the Radian is a really good choice for off-grid applications. We do not recommend it for Skybox. It doesn't have that surge capability. You have to have an AC source connected when you upgrade the firmware. We just don't recommend Skyboxes for off-grid applications. With regards to AC coupling, they both use a technique called frequency watt. So when you're AC coupled with a grid-dependent inverter, it will increase the frequency of the output to, and this is when the grid is down, by the way. So when it's in the off-grid mode, if you will, we become the source for the grid tie inverter, and we can have up to 7.6 kW. And we use this frequency watt technique. If the batteries get full, to protect the battery, we check to make sure that there's no over voltage on the charge voltage. If it goes greater than 0.4 of a volt, we increase the frequency. Same with current. So we protect the battery on both voltage and current. And if the grid dependent inverter is a UL 1741 SA model that has the California Rule 21 code in it, you can put it in that mode, and when you increase the frequency, it will decrease its output. So you can actually regulate the charging on the battery within a few volts. So, yeah. It's just the basic rundown on those. If there's still some questions you have, if you're not familiar with these inverters, you can attend our meeting room after at 3 o'clock. Okay, so these are the SytemEdge packages. It's either the Flex Power Radian or the Skybox you saw on the other page. You can have the energy cell. They all come with the battery racks. So you can have the energy cell or the lithium ion storage. These are the simplified batteries. So you can either get a 2-shelf or a 3-shelf solution. You can always add batteries too. We can't really add inverters. This is a different design. This is just single inverter design, but you can definitely add batteries. And of course you get our, I call it our award-winning optics array monitoring system. If it hasn't won any awards, it should have. It's really an awesome piece of remote monitoring and control software. And then we have our rapid shutdown solution, which we're using the IMO Fire Raptor and the switch, and in conjunction with a relay. So this comes as our kind of our default package. This is good for up to 2 charge controllers. Okay, so you get all of this as part of a SytemEdge package, and they're all UL 9540 compliant, and either like a 2-shelf or a 3-shelf lithium-ion package with simplified batteries. And just wanted to touch briefly on rapid shutdown. I'm not going to go into a lot of detail on this. I do plan on opening the meeting room on this topic though, because we're just now getting our full documentation package on our website. So there might be some questions about how we implement our rapid shutdown. So if you can handle up to 40 modules with this solution here. The power supply internal here will handle up to 40 of these Fire Raptor modules, or 2 charge controllers in most cases. If you need more than that, you would need to go to our rapid shutdown initiator and a 40 to 24 volt power supply. Don't need the relay, and this can handle up to 110 Fire Raptors, which should be good for at least 4 charge controllers. Then we also we don't sell the Tigo solution. I know a lot of people want to use Tigo. The only Tigo module you can use that's compatible with our system due to arc fault and other things is the TS4-S. This is the only flavor, not the O optimizer and not the F. Those are not compatible. This is the only version. Otherwise, you would need to go to our IMO solution. And again, I'm not going to go through these drawings, but they do exist. It shows you how to wire up everything together. This is the IMO power supply and the relay. And then this version is our rapid shutdown initiator and the power supply. So these drawings should be up on our website shortly, but I just want to let you know they do exist, and I'm going to cover it as a topic in our meeting room. Okay, so the other thing is these are the, in addition to the simplified batteries, these are the batteries available from OutBack right now. This is our current lineup. And these are what we call our energy cell batteries. So this one here on the left is the PLRs, the pure lead battery. 200 amp hour AGM battery, has a long float life. It's got a really wide operating temperature range. And one thing that's really unique about this battery and the blue battery, the Blue Plus, is that they cannot be overcharged from a PV array, which is really kind of unique. And that's one of the things that we've seen sometimes in a emergency backup power situation. People will want to go big on the solar. They want to net meter a lot of that energy, offset their utility bill. The batteries are kind of expensive. They might, only have like, 2 strings of batteries on there for emergency backup. But you can, with a big array, you can on a regular AGM battery. It's conceivable you could be exceeding the recommended charging current. So that's not an issue with this battery or the blue battery. So it's really, they're really unique in that regard. So, and the blue has a very fast charging rate. You can charge them super fast. They like to live in a partial state of charge. So between like about 50 and 90%. So you don't need to charge them completely. This makes them kind of good for like off-grid applications. If you are charging from a generator, this would be a good choice for that. The XLCs, these are really awesome battery if somebody really needs a lot of kWh. And they have specifications approaching, like lithium-ion batteries. 3,800 cycles at 50% depth of discharge, which is pretty top end for an AGM battery. 17-year standby life, and they have a full 10-year replacement warranty as long as the batteries are part of have a battery monitoring system that's logging all the data, the charging data and stuff. So, which you can get with Optics RE from us. So this is a battery that was actually used shortly after in Fukushima, Japan, shortly after the tsunami there, when the nuclear power plant was taken out. They put like, I don't know how many, I saw a big room. There was at least dozens, if not, 100 or more of these batteries, all tied together in a massive power center. So these are really, really good batteries. A little bit spendy, but if you look at the price per kilowatt, which we're going to jump to here in a second. So this is kind of a comparison between the batteries. In our SytemEdge packages, we have the blue battery, PLR XLC. These are all 12-volt cells. All the XLC is a 2-volt cell, and the simplified battery is a group of cells and a 48-volt battery. Amp hour ratings, you can see the round trip efficiency is all pretty good on all of these batteries. So the internal losses are really quite small on all these batteries. Operating temperature, pretty robust. The PLR, I think the reason this is only 45 C is because I think a charging spec is a little bit lower than discharging. Same thing on the simplified. They have a lower spec on the discharge, but not on the charge. But you have to charge your battery, so you pretty much have to go with the worst case scenario there. Cycles at 50% depth of discharge. So they're all, on the PLR, if you're just emergency backup, these have a really good float life, like 10 years. And so they're a good choice for somebody wanting to do just emergency backup. 80% depth of discharge, that's not recommended for the blues. They really don't like to be discharged more than 50%. You can see that the PLRs drop from 1500 to 800 when you go down from 50 to 80% depth of discharge. But, if you're just gonna be backing up your home like a couple weeks of the year, 800 cycles is more than enough. And so that's another way of looking at this. But you can see what happens on the XLCs when you discharge down to 80%, you really lose a lot of cycle life. So better to keep these at a 50% depth of discharge. Okay, so just kind of some relative ratings on float and cycling applications, surge applications. The PLR and XLC are really good surge batteries. They are not recommended for the simplifies. So you really need to, and you'll see that we have a, on our sizing tool, we have a surge chart, and I would recommend that you don't exceed the kWh. You know, if you compare that surge spec to your kWh spec on the Simplify, because these are not surge batteries. Shelf life, all got pretty good, the AGMs. Same with they don't specify it with Simplify, but they do have long shelf life. Self-discharge rate is pretty low. Warranty, 3 on the Blue and the PLR, 10-year on the XLC and the Simplify. And I think the Simplify, that's if you only use 80% capacity of the battery. So if you charge up to a lower voltage. So did this little exercise that some of our, our battery team uses when they're looking at a system. So if we look at the levelized cost of energy for a 20 kWh system, and I use just prices I found on the internet, not our suggested retail. So I found the best price I could on the internet. You see the blues, like the initial acquisition cost is low, but if you look at the 0.85 cents per kWh per cycle at 50% depth of discharge, they actually are kind of the most expensive battery. And I know same with Simplifies. If you add enough batteries to get up to a 20 kWh system, that's a pretty high acquisition cost. But they have a tremendous cycle life. So if you're doing lots of cycling, that's really good. The best one is our XLC battery. And then the PLR. And what makes the PLR good is because I use the 80% depth of discharge, which means I only need 2 strings instead of 3. Okay. So let's go ahead and move on to the tool. I'm going to go ahead and switch over to the tool. I'm going to have to stop sharing for a moment. Bring up a new screen. So, Bill, can you confirm I have the OutBack Power website up?
Looks like it's up. Yeah.
Okay, cool. So you come to our main website here, and then click on the installer portion of it. And then we're gonna go up to resources, and we come over to SytemEdge sizing tool. Now there's a string sizing tool, which I'll just show very briefly a little bit later. That's an Excel spreadsheet. If you just want to, do some string sizing on the array, and we'll take a look at why that could be important. But the tool really does everything you need. You just click on this tool, and it comes up looking like this. So the first thing we're going to do is choose an application. If you're not quite sure, the energy management, this would be like if you're going to do net metering, time of use, you're setting up some time use timers, that's energy management type stuff. Emergency backup is just for those times when, excuse me, that we would just gonna anticipate losing power maybe a week or 2 out of the year. If any of you are from California, they're having those public safety power shutdowns, for when there's high fire danger. Then they will shut down certain parts of the state, and people that don't have backup power are basically out of luck. And then off-grid, I think that one's pretty obvious. So, you know, the reason this makes a difference is this. So when I choose energy management, that's a cycling application, okay, as is off-grid. So in these applications, I'm not going to choose the PLR battery, but when I choose emergency backup, I am going to choose the PLR battery and also the simplified battery as well. But I'm not going to have you know, say the blue battery because it's a more cost-effective solution and whatnot. So the other thing is, if I choose off-grid, then I'm going to exclude the Skybox inverter, okay? So, and we've seen people like, you know, get Skyboxes for off-grid applications. They're just not appropriate for that. So what this tool is going to keep you selecting the correct inverter and the correct battery type for the application. I'll show you a few examples of that coming up. So we're going to just stick with energy management right now. Okay, at one time when we first were developing the tool, we were thinking to have maybe just a single inverter like the Flex Power 1, or maybe 3-phase, and we decided not to do that. So this really isn't a choice. It's split phase or split phase. So now we come down to developing the load profile, and this is really important. I went on to some of our competitors' units, especially the ones that are selling high voltage batteries, and they ask you for a zip code and the square footage of your home. So I did that, and I know what my average daily kWh is. And I went in through the whole sizing exercise, and it pretty seriously undersized the system. And so this really is the most accurate way to do this, is to go through and say, okay, and we kind of pre-populate this so you can kind of get an idea how to do this. Like the refrigerator, one, it's 75 watts. Now, typically, like a refrigerator, it's a cycling load. It's on like maybe 15 minutes out of every hour. So if you were to, but we kind of normalized it over like 24 hours a day. How much would it average, you know, per hour? And how many days per week? And you can go to the drop down. You can choose a different, you know, different load. So they're all in here. You can also go all the way down to the bottom, and you can just choose a custom load. Now, we don't have the ability to give custom names right now. That was one of the things we just kind of ran out of time. We wanted to get this out and available to people, but the next rev, we're going to make it so you can give custom names. So it's just custom 1, 2, 3, 4, 5, 6, up to 9 different custom loads. Okay. But this is a really important exercise to do, and not just for accuracy of sizing the system, but also just to kind of do some what-if scenarios with your customer. But before we get to those, I just want to show you a couple things. So the total power, this is what the SytemEdge calculator is operating from. It says, okay, if I turn all these loads on all at once at the same time, I need, you know, a peak of 2.3 kVA, okay? And then my surge is 5.4. So any kind of surge load, like we have the microwave, that's gonna have some surging when you first turn it on. I bet I'm not the only person that's popped a circuit breaker with the microwave and the refrigerator on at the same time. So we definitely get some surging there. But let's say you had a load that had a soft start, then you could change that number. And let's just kind of take a look here with just this default configuration. I'm just going to hit the calculate key. Okay, and that's going to show, based on the information we've provided, the application and the loads, what are the different options. And so we have the 4 kVA, the 4 kVA radian, and we have the 8 kVA radian, but there's no Skybox, okay? And we're showing the surge. And here's the effective storage. Now, here's another thing that we do is we don't use the nameplate storage. Like on a AGM battery, we spec it as 50% depth of discharge. When you see the Simplify batteries, this number is based on 80% depth of discharge, because that's what they recommend is for the 10-year warranty. So this number here comes from up on the table over here. So when we have a load, and we, like in this case, we have 5 CFL bulbs, or most likely LED bulbs these days. That's 150 watts, 4 hours a day. And then when we have how many days a week? And the reason we ask days per week is we might have some loads that are only used like 5 days a week or 3 days a week, like a laundry machine, or hey, I only use my microwave on the weekend or whatever. So this kind of normalizes it into a 24-hour period, because that's what this tool is designed for, is to provide backup power for 24 hours. Okay, so even though we have different days of the week and blah, 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 this kWh, this number here, is the number to get you through 24 hours, because that's in coincidence with the solar day, right? So when you deplete your batteries overnight, or down to that 50% or 80% depth of discharge, then you know that the sun's going to come out the next day and recharge your batteries again. All right. So now the reason that Skybox didn't show up, remember we said that it didn't surge above 5.4. So let's say that that my microwave has some surge protection into it. It's one of these modern microwaves that doesn't surge. They put some protection in there, and it's much lower. Okay, so now we're below 5. And I get down here and I can see now I have some Skybox options in here. This is where the 5 kV is. So I've got my Skybox options in here. Okay, so I'm going to put this back up here. In fact, I'm just going to change loads altogether. I'm going to change up to a central air conditioner. So I've got a central air conditioner. I'm going to recalculate, and I've got one option, right? Because the total the kWh is so high, the only option that can handle that, and same with the surge, the 8 kW radian can handle, is the only one that can handle the surge, the total power, and the XLC, the big 2-volt cells, are the only ones that can handle the energy. So let's say that kind of broke the budget of your customer. Okay, so now you can kind of talk about some energy strategies, like, okay, Mr. Customer, we know you like your air conditioning in the summertime, but what if rather than backing up your central air conditioner, what if we put in like a mini split that was 1500 watts, okay, instead? Okay, now we recalculate, maybe we just have a cooling room. Okay, so we put a mini split in like, the family room, or, the basement or somewhere like that. And then when people get too hot, they could just go cool off in the cooling room and could save a lot of money. Now we have more options. Now we got 3 more options available to us. We've got the Simplify 16.8. That's the the 6 battery solution. Now, another thing that you could have done here, if you look at this, you say, okay, I need 24 kWh with that central air. You could add another rack of Simplify batteries, okay, if you still wanted to use lithium ion instead. So when we came up and it only showed this bottom solution here, we could have just say, okay, everything else is the same between these packages. I'm just going to add some more Simplify batteries. And maybe that's the way you want to go. Okay, so there's a lot of flexibility on this, and the thing that's nice about it is you're not going to have the design, configuration, sizing issues that so many people come up with, and even with other online tools, they're going to give you an overly optimistic picture. And I've worked with so many people that, you know, after the install is all in, and they're just like, oh, the customer's not happy. We didn't do this right. We didn't design it right. We didn't size it right. We didn't program it right. Whatever it was. So we're going to go ahead and select one of these packages. We're going to go ahead and go with the Flex Power Radiant, 8 kW Flex Power Radiant, and the 6 Simplify batteries. Okay, so now we need to go and pick out some solar modules, and you know, we'll do some string sizing here. So we can do, we have the option of choosing Celsius or Fahrenheit. We'll go ahead and choose Fahrenheit, and let's pretend like we're in, like, you know, Massachusetts or New Hampshire or something, where I know a lot of you guys are. Let's say -20, and you know, it can get a little bit warm there in the summer. Okay, and 95. Okay, and then we need to choose a module. So we're going to choose a Canadian Solar 340. I know there's a lot of new modules that have come out since. You can actually choose, I think at the very bottom here. It's not here, it's input custom data. That's this little button right here. So if I wanted to, you know, put in my own custom module, you can do that. Okay, but for right now, we're going to go back and choose the Canadian Solar. We're going to calculate a string size with the selected module. Okay, and it's recommending 4 strings of 5 modules per string. Okay, and now if you want, you can try and do some customization. You can say, well, gee, how about if I wanted to do three strings, but more in series? And you go, oh, I can't do that. It's showing us what the maximum VOC is, but it's just not working out. So maybe we do have to go 4. Now, remember I showed you up here that we have the string sizing tool. So it's a little spreadsheet string sizing tool I did once when recovering from knee surgery. And so if we come to this tool, we can come over here and we can select any one of 4 different OutBack products: Skybox, FM100, FM80, FM60. We'll stick with the FM100 because that's part of our Flex Power Radiant. And we say, okay, we got a 4 strings of 5 in series. And we can see that works out. If we were to go to 6 in series, now we're exceeding the rating of the 300 volt rating of the charge controller. Okay, so we could fiddle around with temperature. Over here, we could try different string sizes. We could try different modules. Now, one thing you can do here that you can't do on the online website with regards to string sizing, you can add this here and you can save it. So if you've got like 5 or 10 modules, or you get a new module that you really like working with, you can put it in here, save it, and then when you come on the drop down, you'd find it at the very bottom of the list. Like these ones I added over here on the module data.
Hello, Mark. Mark, Bill Dougherty here. There is an indication that you switched to your spreadsheet, but it is still sharing the website screen.
Ah, yeah. Sorry.
No problem.
Thanks. Okay. One thing that's different about Zoom versus GoToMeeting. Okay. So anyway, this is a tool. I don't want to spend a lot of time on this. I'm just saying if you want to figure out what your real limits are, this is going to tell you what the voltages are with different numbers in series. If you wanted to kind of get down into the nitty gritty of string sizing, you can do that. It's certainly not required. I just wanted to point that out. So again, we can talk about this more in the meeting later and in the meeting room. But if we go to back to the online tool, we don't need to do that. I mean, it tells you what the numbers are, and it's going to give you the right solution. But you can customize it. You can do some changing around if you need to. When everything is all said and done, you can go to print results. And it will print out, cancel that for a moment. It will print out all this information. Hold on a second, let me go back to that print screen again. Can you see this, Bill? Can you tell me, can you see, or is it coming up in a window you can't see?
I can see it. Thanks.
You can see it? Okay. So here it shows you all the results. So it shows you that the loads are there. It shows you the SytemEdge package that was selected. It's a single SKU. Shows you what all the environmental data and the specifications of the solar module that you did. Shows you what the string configuration is, maximum array size, and your voltage limits. So you would need 20 of these, but you got 2 FM100s, so you would actually need to order 40 of these Canadian solars. So you've got this on your one item on your bill of materials, and then the SytemEdge package on the other. And what's nice is you have a nice little proposal that you can put to your customer, and it's also kind of covers your back too. With if something doesn't work out later, you can say, but this is what I sized it to. You know, whereas if you're sizing a system to zip code and square footage, it's much more of a crapshoot, if you will. So with this system, you really have a more precise system. It's still fairly easy to use, and you have a really well documented proposal that you can make for the customer. Okay, so it looks like we have, this is pretty much all I have for now. So I'm happy to entertain some questions. I don't know, Bill, you came across, if you came across any that you might not have been able to answer, we can go ahead and take on some of those questions now if you like.
No, we're pretty good. A lot of great questions occurred about Skybox and a long-term outage, extended outage. And, I highlighted that, hey, the reason why it's not recommended off-grid is because of the limitation of a 5,000 watt surge. Yeah. But it would be fine in a extended outage situation. And also a question about Simplify and the new closed loop networked battery that Simplify has, and is OutBack going to integrate that? And indicated product management, we'll evaluate that and make a determination. Mm-hmm. And we do offer the Simplify 3.8 kilowatt hour option today. There was a question about 2-volt cells with the PLR, I believe it says XLR, but the 200 PLR is available in 12 volt today. And of course you can stack it to 24 or 48 volt, depending on the application. And then there was a question also, Mark, about, it said 200 kilowatt hours of usable power. So Mark, I believe that was either regarding the 200 PLR or the 1000 XLC.
Right, so all the AGM batteries, well, the Blue Plus battery and the XLC, we use a 50% depth of discharge. And on the PLR, we actually use 80% because we assume that people won't mind giving up some cycles in an emergency backup application. But you would never want to have a PLR for a cycling application. So that's why selecting the application is so important on this. So, hey, there's some other questions that have come up here, Bill, that I'm going to go ahead and try and answer.
Oh, sure. I didn't see him. Thanks.
So one is, does SytemEdge use FlexNet DC for the SOC calculation? For simply, I've seen a large discrepancy between the voltage and SOC as compared to documentation. Never get to 20%. Yeah, so what happens, the SOC calculation is really, it's a tricky calculation to make, especially when you do partial charging, okay, and partial discharging, and you don't get a new charge cycle in. If you are charging your batteries every day, then the SOC will get reset to 100% every day. But if you go like days and days and days, or even like a week or two or more, you're going to get compounding errors on the SOC calculation. So make sure that you have the FlexNet DC set up properly, and from there. Now, in terms of the simplify, and you mentioned that it seems like you never get to 20% as the voltage drops off faster. Yeah, it's really, a lot of it depends on your discharge rate too. If you're doing a fast discharge, and I've seen a lot of undersized systems, and in terms of simplified batteries, because they are more expensive, people try and get by with as few as they can, which means that they're discharging at really fast rates, and so you're going to get some less capacity that way. So I'm going to go to the next question. How did you come up with a total of 40 panels? Now, if you can still see my screen, we're going to do 4 strings of 5. That's 20. And there's 2 FM100 charge controllers. So it's 20 for one charge controller, 20 for the other. Okay, so somebody wanted to talk about AC coupling. I think I did talk about that briefly when I was comparing the 2 inverters. So, I mean, it's just one of those things. Your AC coupling is always going to be a little bit harder on the battery because, and that's only when you're in like a backup scenario, right? When you lose the grid and, and you're in backup power mode, that is going to be, because batteries like to be charged at a set voltage, a real stable set voltage, and you just don't get that with AC coupling. But come to the meeting room at 3. Happy to answer more questions about AC coupling. Okay, so we have some more questions coming up here. Can Skybox be added to an existing radiant system as an expansion? No, it cannot. They're not compatible. You could add it as a completely separate system that had its own load panel. I'd say so, but even having them sell back to the grid in parallel could be problematic. What about using iron Edison type batteries? No issues I know of. I know people, a lot of people are using iron Edison batteries with our inverters. I've been in touch with losing his name, Hendershot, I think it is. And we've talked a lot about batteries, and from what I gathered, they're working just fine. And Daryl Thayer, how you doing? Haven't seen you in a while. How does the sizing tool account for sunlight for extended cloudy periods? So this is the one thing that's a little bit different than sizing tools we've had in the past, right? So you have a SytemEdge package. So what we do is we just try and maximize the most amount of solar that we can for the number of charge controllers. So there's either 1 charge controller or there's 2 charge controllers. Or in the case of the Skybox, there's a maximum of 6,500 watts connected FM100, maximum 7,000 watts connected, but neither one is going to do much over 5,000. Well, for sure, the Skybox won't do more than 5,000. Basically, you know, the wattage with the FM100 is, you know, 100 amps times whatever the battery voltage is. So, you know, 5,700 watts maximum probably. So we're not taking seasonality into it. We're just trying to give you the most solar that you can. And if you use the sizing tool, it should come out okay. But again, yeah, you know, we could have added some complexity to the tool. We're gonna leave it to you on, you know, if you may have to add a generator. I mean, that's just, that's actually quite common with systems if they fall short on solar. Okay, Glenn Burt, that 40 modules is really not apparent in the tool. Yeah, you're right. I had actually asked them to do the math on that because, but if you go up, if you look at the SytemEdge package, it says, I'm going to move the Q&A box out of the way here for a second. It says 2 FM100s. So yeah, it kind of is what it is. I agree with you though. That's definitely going to be in the next revision that we should do the math for you. Do you have to size differently for Iron Edison? You know, not that I know of, but you know, I would talk to them. Again, Hendershot, he's done a lot of, he's been pretty tightly involved with a lot of these installations and whatnot. I would contact Iron Edison about that. Do you have to size differently? Yeah, you could, you know, boy, it really kind of depends on the battery. You know, if you wanted to use this tool for that, you could try and match kWh to kWh and it would probably come up pretty closely. So if it says, hey, you need a, you know, we're gonna provide a, let's say your 24-hour load is gonna be 20 kWh and we tell you the next increment battery is 24 kWh, then, and you found a 24 kWh Iron Edison configuration, then yeah, it should satisfy that, but it's not going to be all 9540. You're not going to get the SytemEdge package price and everything else, but yeah, you could do that. Okay, XLC batteries.
Mark, the question here was, do we sell the 2-volt cells individually and for the 1000 XLC, and we do not. So that was the question there.
Oh yeah, yeah, okay. Perhaps consider integrating the sizing tool with the way they pull weather data for PV watts to make it a little more accurate for average weather. But at least anybody designing the system should run that once they know the additional details. Yeah, I agree with that. That's, you know, it's one of those things that is kind of like we application engineers, and we came up with a sizing tool that was multiple inverters, multiple charge controllers, and we would size inverters and charge controllers kind of differently. But with SytemEdge, you get one inverter and either 1 or 2 charge controllers. So there's no like adding a third one or deducting one, or, you know, it's not like creating a big system. So it's a little bit different than that. But yeah, I would definitely look at the weather data and see, you know, and you could apply different efficiencies. I think our default array efficiency is 75%. So you could take, you know, what we would think that we could satisfy with solar over that same period, and see whether or not, you know, if you apply a lower efficiency, like a wintertime efficiency, and then you say, oh yeah, you know, maybe we'll add a third charge controller and you know, another rack of batteries, you know, and you know, especially if you're doing an off-grid system. I think for most cases, if you're grid connected, that these systems, if you get the load calculation correct, you should be in good shape.
All right, Mark, I am looking at the time. I think we're getting ready to go to the next session.
Okay.
Great questions, though. This was fantastic. Thanks, everybody, for bringing them in and good answers. Well, great answers, really, right, Mark? All
Thanks,
right.
Jay. Thanks for hosting.
Yeah, well, thanks, everybody, for joining us. And we have another session starting in just a few minutes. And then don't forget about the networking conference where you'll actually be able to talk face-to-face to people instead of the one-way format here of the webinars. We're going to have that starting at 3 o'clock. All right, so we'll see you later then. Thanks, everybody. Take care.
Thank you, Jay.
Thanks, guys.